Data scientists frequently have to handle missing data. But without paying careful attention, it's actually very easy to run afoul of some tricks and problems. The first thing is blank data comes in many shapes and forms. It might come in the special null value, which is the explicit programming type for not having data. It might be a blank, which is 0 characters in a field. It can be sometimes a special code like 9999 or -1, and you have to go and look at documentation. Or sometimes, Excel will fill 0 for you, and when we upload it, we'll have data sets that wrongly have zeros where there should be missing data. When you have blank data, there's a few ways that you can treat it. The first thing is to throw out the row altogether. Some of the functions like regression might fail without removing that blank row. Or, if we care about the value that's missing, we don't have any ability to use that data anyway, so we should just be cleaning it out and removing it. Other times, not having data might be meaningful. For instance, a row is recorded when the value exists, but it's left as blank when some condition is false, and actually what we're trying to target is whether the column is filled or not, and we actually do care about the blank data. Finally, there's other times where we can kind of infer what it's supposed to be and fill in the value of the data, whether it's a 0 or a blank. We can actually go and say, oh, I actually know what this means. It should either be filled with a false, it should be filled explicitly with a 0. Maybe I need to replace a -1 with a 0, and we can actually go and make those replacements. As a practical example, we can take a look at this data set, which represents a marketing promotion. We offered some individuals a cash incentive to renew their lease early, and they may have accepted the offer or not. Here we can see that the acceptance of the offer was coded as true, but not accepting the offer was actually left as null rather than as explicitly false. This is probably okay in most cases, but if we wanted to clean up the data set just for explainability purposes, maybe something we could do here is write a quick line of Python and replace the null value with a false value explicitly. Now we can see rather than true and null, we have true and false. The next thing I might do is try and scan across some of these data set values and see if they all make sense. I can quickly profile and maybe sort by the number of null values. And I can see that there's actually 24 rows in incentive with null. I could probably go and actually chat with my business stakeholders here and realize that null probably refers to $0 of incentive, and it was just not properly filled in. So I can actually go ahead and replace incentive. This is actually something I need to take care of, because if I leave it as null, it could be misleading. Maybe I would fill in the incentive column, filling the NAs with 0. I can also now sort by number of zeros. I see that there's actually a number of leases where the lease length was 0 long. I see the same number of rows in lease length, lease price, purchase price. It's quite possible that there are some folks with incorrectly coded information. I could maybe visualize some of these and see that there's some with 0 here that could make sense. But I also see that some with the purchase price is 0. That does not quite make sense for a car. So I could, at this point, either remove those data sets as flawed rows and remove them altogether, or I can recode them as nulls explicitly. In this case, maybe I'll just go ahead and remove all those with the least length of 0. And now in my clean data set, I can come through and I have recoded incentive with 0, accepted with false, and removed all the rows of zeros. And I can see now there are no zeros left in my data set, and maybe I feel comfortable with the cleanliness